Bonjour. Welcome to Wahsa Distance Education Center's radio Zoom classes. This is MEL3E, grade 11 workplace math, and I am Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link. Whether you'd like to ask me questions or just watch along, that's fine. But the link is available from me, your teacher, and also from your DEC. Our classes are scheduled Monday through Thursday from 9 till 10 in the morning. And we are now in our 7th week of our 9-week course. So at this point, our last day to submit work for me to accept work is June 10th, which is coming up in just a few weeks. So a reminder that the support questions are not to be submitted for marking. They are practice problems, and you can decide which ones and how many to do. If you are understanding a concept, feel free to skip questions. You don't have to do them all just because they are there. But if you need more practice, please ask for more practice and I will hook you up. So you need to figure out what is best for you and advocate for yourself. The key questions, the ones with the little key icon, those are the ones to submit for marking. So please do all of these questions. Don't skip any of these ones, do all of these ones. Showing all of your work, your steps, and your thinking. This way I can understand what it is that you understand. And if you're making errors, it gives me more information to help you. So please show your work. I know it takes more time to write, but please show your work so I can give you credit for all that you understand. There are 3 different methods for submitting work. The first is to scan your work in and send it electronically. So if you have a smart device, you can scan your work using an Apple device with a Notes app, or if you're using an Android device, you can use a Google Drive app. Both have fairly straightforward scan functions. If that's not something you're comfortable with, that's fine. But then you can just take pictures. They're just a little bit larger files and can be a little bit awkward, but it's totally fine if that's more comfortable for you. Then you can send them to me either through email to studentwork@nnec.on.ca and CC it to brodwin.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. Second method is to drop your work off into Lookout. We have an outdoor mailbox at 74 Front Street, or the bright red building next to the post office. And we have a small white mailbox next to our side entrance. So you can just put it there at any time. Or the third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. So you can friend me on Facebook or subscribe to my YouTube channel. And this way you'll get notifications every time I upload one of our lessons. All of our lessons are recorded and I upload them to YouTube within a few days of airing. There's also short videos on my YouTube channel explaining common errors or confusing concepts. So if you're making a consistent mistake, then this might be a place to go check out to see if there's something that might help you understand why you're making that mistake and how to improve. You can then do a general internet search, but it might just be a good place to start if you're struggling with something. Math is a really visual subject, so I strongly encourage you to access the videos. Either joining me live through Zoom or watching the replays on YouTube are really going to give you the most information about what it is that we're doing and how to understand what it is that we're doing. So if you can't access the videos, let me know and I can send you a copy of them on USB key or something so that you have access to them and set yourself up for the most success. If you have any questions or concerns, please reach out to me. Again, remember our last day to submit work is June 10th. This includes your culminating activity. So once you are finished all 20 of your lessons, you have a final project that connects all of the learning that we've done and wraps it all up. That is a take-home project that you have for a week or a few days to work on. It does take time though. It is not a short thing. There are various parts because it covers the whole course. So it's really important that you give yourself time before June 10th to have all of your work finished so that you can then get that culminating assignment and get it in before the June 10th deadline so that I can do all my marking and get all of your grades in before we close a week later. So really, really important. Get your work in. If you're having questions, if something you're struggling with, reach out to me so that I can support you. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslatewasa. My phone at the office is 807-737-1488, extension 2209, or you can call me toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 4 p.m. So feel free to reach out to me directly during that time, though I teach the first hour and the last hour of my day, so I'm not available during those times. All right, so today's lesson is lesson 17, and this is talking about traveling distances, specifically in a vehicle. So at the end of this lesson, hopefully you'll be able to use a paper map to estimate traveling distances. You'll be able to use an electronic map to estimate travel distances and predict travel duration, how long it's going to take you to travel. And you will understand how weather conditions influence travel times. So you know you've met our learning goals because you can use the given scale and the given data to measure distances between places, generally on a paper map, but you can do that electronically as well. You can use Google Maps to find distances and estimates of travel times. And you can explain how bad weather results in longer travel times. All right, but first let's activate our brains and do some mental math. I believe that math facts are useful tools, but drilling them and memorizing them are not the most useful ways of being comfortable with them, depending on who you are. If that works for you, that's great, that's fine. But many of us need strategies that we can use in different situations. So we work on developing those strategies to set everyone up for success. All right, today's question is 64 divided by 8, and we're using the concept of proportional reasoning. So division is something that many folks struggle with. Long division is just, many of us learned it as a list of steps, and it's hard to remember all those steps, and it seems arbitrary why we do things. So this is thinking about division conceptually, about what's going on. So proportional reasoning is the idea that we are comparing things in the same proportion. So the same amount of things so that you have the same ratio. So you still have the same ratio of French fries to kids at dinner time, or cups of water to cups of juice if you're making juice or something like that. So that means that we are going to split up the total amount of things that we have, which is 64, and the number of groups, 8, that we're dividing it into. So we could do this in any way that we want. The easiest way to start with, something that I find the easiest, is to cut things in half. So I'm going to cut 64 in half. And 64 in half, well, 60 in half is 30, and 4 and a half is 2. So 64 and a half is 32. And I'm going to cut my groups in half as well. I'm doing the same amount because I'm keeping the proportions the same. So 8 divided by 2 is 4. Okay, so that is a good start. I have smaller amounts. Now it's just like I have 2 groups of 32 that I want to split into 4 groups each, is the kind of the idea. So I'm going to do it again. This is still, I don't know what 32 divided by 4 is. So I'm going to divide it by 2 again. So I'm going to cut in half. So 32 things, well, half of 30 is 15. Half of 2 is 1. So 15 plus 1 is 16. And I'm going to divide 4 in half by 2. So 4 divided in half is 2. So now I'm left with dividing 16 by 2. So I cut it in half and cut them both in half again, but that's still just the same. So 16 divided by 2, well, I know half of 16 is 8. So that is equal to 8. So that means that if I take 16 things and I divide them into 2 groups, I get 8 things in each group. And that is the same as that if I get 64 things and I divide them into 8 groups, I get 8 things in each group. And that's how proportional reasoning works, is that you're just sort of, it's like you're simplifying, you're paring down your totals of your things in your groups in order to be able to deal with what it is that you have. Okay, mine's on. What do we need to know for today's lesson? We need to know about cross multiplying and dividing. This is not a tool that I love because it is a step-by-step process, but we don't really have time to go into the algebra behind what is going on, or to really, because we're virtual and through distance education, we don't really have, ideally, if we were in a classroom, we would do some activities that would make this make sense. And we can't do those activities because I'm talking to you on the radio or through YouTube, and that giving you a hands-on activity doesn't really work. So I'm going to talk through the steps of how to do cross multiplying and dividing, because we'll need this later on. If this is something that you're struggling with, or that doesn't make any sense to you and you want to talk to me about it, feel free to reach out and we can work on it together. If I'm talking directly to you, then we can do some things that might be a little bit different, opposed to if I'm just talking to the void where you are and I don't get any feedback. This is probably something that you have learned. And so I'm just going to stick to the classic way of doing this in order for it to make the most sense to them, hopefully the most people. Again, if this is confusing, this doesn't make any sense to you, please reach out and I will support you to help you work through it. So when we have 2 ratios or 2 fractions, even when we have 8 divided by 12. So we have 8 things to 12 is equal to an unknown amount. So X to 30. So we're trying to figure out how these 2 things can be the same. That's our goal. So one method that works consistently, you can follow these steps and you can get the right answer if you follow these steps, is to cross multiply and divide. So what that means is that we're going to multiply our top number by the opposite bottom number. So our numerator by a denominator on the opposite side. So we're going to have 8 times 30 is equal to, and then we're going to multiply our denominator times our numerator on the other side. It's equal to 12 times X. So 8 times 30, well, I know that 8 times 3 is 24. So 8 times 30 is going to be 240, is equal to 12 times X. So that's just 12X. So that's the multiplying part. And now we're going to divide. So we want to get X by itself so that we know how much X is equal to. So we're going to divide both sides by 12 because 12 is in front of our X. So we have 12 X's. So we're going to divide it by 12 to figure out how many 1X is. We do that on one side, we're going to do it on the other side. 240 divided by 12. Well, I know that 24 divided by 12 is 2. So 240 divided by 12 is going to be 20, is equal to X, because our 12s cancel off. 12 divided by 12 is 1. So in this situation, 8 over 12 is equal to 20 over 30. Those ratios are the same. So that's how we cross multiply and divide to figure out an unknown. This way, this is how we do it when we have our unknown is on the top in our numerator, but we do exactly the same thing in the second example where our unknown is in our denominator. And that's why cross multiplying can be helpful, is because it doesn't matter if our unknown is in our numerator or denominator. It's on the top or the bottom. So we're going to do the same. We're going to cross multiply. So we're going to do our top times our bottom across our equal sign. So we have 63 times Y is equal to 108, sorry, crossing 108 times 9. Well, 63 times y is just 63y. And 108 times 9, well, 100 times 9 is 900, and 8 times 9 is 72. So that's going to be 972. And now, so we did the multiplying, and now we're still going to do divide. We're looking for y to be by itself, because that's our unknown. We're trying to figure out what y is equal to. So it's like we're saying 63 times what number equals 972. So that means that we have to do 972 divided by 63 to figure out what that other number is that multiplies. So we do 63y divided by 63 to cancel those 63s off, so that we just have one y. And we do 972 divided by 63, because we're trying to figure out what number times 63 equals 972. Now that division I don't have in my head, and I don't want to spend the time going through it. So 972 divided by 63 is equal to 15.4. 15.4. So y in this situation, y is equal to 15.4. So it doesn't have to be a whole number, can be decimal, but this is saying that the ratio of 63 to 108 is equal to the ratio of 9 to 15.4. And that's how cross multiplying and dividing helps us with our ratios. Again, this is just really functional computations. I haven't really explained the why of it. We don't have time to really dive into that here. This is hopefully a tool that you've been exposed to before and makes sense. If it doesn't, please reach out to me and we can work on it together. So the other thing that we need to figure out is when we're comparing ratios, how we know how to set up our ratios. So we just did the calculations, but how do we set it up? So we're going to compare ratios. We're going to do a couple of examples of comparing ratios. So here's our situation. Darnell and Lester took a fishing trip with their scout troop last week. Darnell caught 4 catfish and 8 trout. Lester caught 3 catfish and 6 trout. Did the boys catch the same ratio of catfish to trout? So how do we figure out if those are the same? So what we need to do is we need to set up a ratio comparing Darnell's catches to Lester's catches. And how we do that is we say, okay, catfish to trout for both of them. Catfish to trout is equal to catfish to trout. So this is the key part, is that you need to set up your ratio so that you are comparing the same in the same order. We don't want to have one to be catfish and trout and one to be trout over catfish. We're comparing trout to catfish. That doesn't make any sense because we're not comparing the same thing. We need to be comparing the same thing. So we want to make sure that they're set up in the same order. So Darnell's catfish to trout ratio was 4 catfish to 8 trout, and Lester's was 3 catfish to 6 trout. So we're wondering if that's the same. Really, we should have a little question mark kind of. Well, 4 over 8, well, that's 1/2. And 3 over 6, well, that's 1/2 too. So we see that they are the same. They have the same ratio. Even though Darnell caught more fish, they still both caught twice as much trout as they did catfish. And because we ordered them in the same order, we can actually compare these. So this actually makes sense. Okay, let's do another example. Different situation. Regan and Tisha are using roses and carnations to arrange bouquets for Bud Time Flower Expo. Regan plans to use 6 roses and 4 carnations, and Tisha plans to use 5 roses and 3 carnations. Whose bouquet will smell more like roses? So whose bouquet will have more roses, in like who will have a higher ratio of roses? Because yes, Regan has 6 roses opposed to 5 roses, but is the ratio comparing the carnations, is it the same? So we need to do the same thing. So we're going to set it up the same way that we have Regan's bouquet and Tisha's bouquet. And we want to set up our ratios. So we're saying roses to carnation, which means that we're comparing roses to carnation. We need to do it in the same order. In these questions, I have given you them in the same order. I've said roses, carnations. But even if I had written this as Tisha plans to have 3 carnations and 5 roses, you still need to set it up so that it's rose to carnation in the same order. It could be carnation to rose, that's fine, but it needs to be the same for your exact, for whatever it is that you're doing, it needs to be the same. Rose to carnation, carnation to rose, carnation to rose. It can be either way, but it needs to be the same in your question. This is a way that we can have different, our work can look slightly different, and our answer might be a different number, but our meaning would be the same as long as we set up our ratios in the same order. So Regan has 6 roses to 4 carnations. And how does that compare to 5 roses to 3 carnations? Well, here this is kind of like, well, I don't know, how does this compare? So what we can do is we can actually just divide these and see which one is the bigger number. That means we're going to have more roses. So 6 divided by 4 is 1.5. And 5 divided by 3, well, there's 1 whole there. And then, so we have 1 whole, then we're going to have 2/3 left, and 2/3 is 0.67. So that means that Tisha's is greater. This has greater rose smell or greater rose ratio. So it doesn't really matter in terms of the answer. That's not what's important for us right now. The important part is that we need is this part where we set up our ratio in the same way. This is so important for comparing to what we're going to do today. Okay, so that's a lot of setup. Let's dive into our actual new material today. So when would you use this in real life? Well, we are learning how to make decisions and justify them. This is all about traveling. Many of us need to travel. We drive around. Living in remote areas means that we have to drive places, and being able to decide how to get there and what's the best pathway is really what we need to do. So we're learning how to make those decisions and how to back them up and just justify why they're the best ones. All right, so first, estimating distances on maps. This is on page 16 of your IEL booklet. So rarely are there 2 places on a map connected by a straight line. So estimation is used to calculate the distance between 2 locations. To use estimation effectively, the scale must be given on the map to calculate distances. These scales are usually given in one of the corners of the map. So a scale tells you what this, the distance on the map, what it represents in real life, because we don't have a map that has an actual kilometers saying this map shows all the kilometers. It's not realistic to have a map that shows it in real distance. That is way too large. The whole point of having a map is that it's a shrinked down version of what it is in real life. So here is a picture of a paper map. Maybe you are familiar with it, maybe you are not, but this is a picture of what a paper map of Ontario looks like, of Northwestern Ontario, Northern Ontario. And the scale, if we zoom in, so here, it's hard to see here in this spot in this corner. If we zoom in, we can see there is a scale. So it has something that says map scale, and it tells you what your scale is. This is in both English and French, because in Canada, our official languages are English and French. So this is saying that it is a scale of 1 to 1,600,000 units. So here it's saying 1 centimeters is equal to 16 kilometers, or 1 inch is equal to 25 miles. And you can have that. They actually show you this physical scale that shows you that this from here to here is equal to 20 kilometers. From here to here is another 20 kilometers. So from here to here would be 40. From here to here would be 80 kilometers. And then you can also break it up into even smaller, into 5 kilometer bits. And the same thing for miles. If miles was something that's useful for you, we're not going to care about miles right now, but this is gives you a rough estimate. So you could use a ruler or a string or something to figure out, to measure, to give you an estimate of those distances. So on Google Maps, which is the most common electronic map that I know of, I don't know if there's other maps that people use that are electronic maps. I think Google Maps is fairly constant. So here in this the bottom right hand corner is your scale, where it says, let's go visit it. So here, I'm just going to, you can see here it says 200 kilometers. So this space here is equivalent to 200 kilometers wherever you are. And as you zoom in on your map, now that distance here is 100 kilometers. And I zoom in again, and I can see that it gets bigger and bigger. So that's really important to realize, is that if you're using a digital map, the scale is still there. It's generally in this bottom right-hand corner. And depending on how close or how far you are, that number is going to change. Okay, so going back to our, oh, right. And then in your booklet, it's a little bit different, of course. So these are for your questions that you're actually doing in your IEL booklet, for your support questions and your key questions. They show it a little bit different. So it's still very obvious. It's distant, it's separated from the rest of your work, or sorry, the rest of the image. This picture that shows the scale, and it has, some of them have both miles and kilometers on them. So kilometers here is 5 kilometers and 2 miles is up here. So this is saying that this distance from this line all the way over to this line is equivalent to 5 kilometers on this map. And from here to here is equivalent of miles. You don't need to know the miles for our work right now, but it's just there for your own information. So you're going to use that scale in order to do your work. Okay, so to actually estimate your distances, there's a few steps. So step 1 is to measure the scale given on your map and write it as a ratio. So I'm going to talk through these steps, and then we're going to go through these steps and actually do them. Step 2 is to use a ruler to measure the distances from 2 points. Only measure straight-ish distances. So you're going to have to, again, I'll show you, if you have a curve, then you need to stop and measure sort of that distance and then measure the next distance that is straight. I'll show you. It's easier to see than to just hear. Then you add those estimated distances together. Step 4, write an equation with a scale and an unknown x to represent the distance in kilometers, and then step 5, solve for x using cross multiplication and divide. So those are your steps, but let's walk through what that actually looks like. So we're going to estimate the distance from Jeremiah McKay Kabashi Wakamatnik. Sorry, I'm probably not pronouncing that at all. The number 2 hostel in Sioux Lookout, which is down here, to Fresh Market Foods, or Johnny's as most people call it, the grocery store in Sioux Lookout. So we want to measure that distance. Now, in order for me to show you, I'm going to use a tool. I have this ruler that you can see. So first thing I need to do is I need to measure my scale. So I'm taking my ruler down here and I'm lining it up and I'm saying, okay, so I'm lining up my ruler. It's a little bit awkward on here, but it looks like, okay. Oh, and I want it to be in centimeters, not in inches. It's like, that looks too big. Okay, so here I line up 0 to one end and I go to the other end and I see, okay, that looks like it's about 18 millimeters. So 18 millimeters is equal to 200 meters. So what that means is, for my first step, I'm saying 18 millimeters is equal to 200 meters. It is okay that my units are not the same, because I'm going to then have my ratio. I'm going to have millimeters, and that's going to be able to figure out how many meters I'm looking for. So in order to do this, we are going to approximate. We are estimating. Oh, come on, please just switch for me. Okay, so it is okay. This is not a straight line here, but we're estimating. So it is fine. It doesn't have to be perfect. So that looks to me, it's about 15 millimeters. So I can then make a list so that I know what I can track. 15 millimeters is my first part. Okay, so now I'm going to, that got me to about this intersection. Now I'm going to move my ruler and I'm going to measure. So here, this is my next straight part, and then I have a turn. And so I'm going to stop here. So I'm going to say, okay, I'm going to measure from here. And again, remember, this is estimation, so it doesn't have to be perfect. So that looks to me, it's about 25 millimeters. And then I'm going to go from here and from here into the big corner. It looks like I'm going to say 28 millimeters. And then from here, so continue to turn my ruler. I'm just going to say, even though this is not, yeah, I want to take this big long space and I'm going to say, okay, that's about 70 millimeters. And then I'm going to, because for the sake of time, even though there's a curve here, we are estimating. So it's all good. It's estimation. It doesn't have to be perfect, right? We're not looking for an exact answer. We're looking for a rough idea. So even though this is a bit wiggly, I'm just going to say that it's about 50 millimeters. And then off this way. And from here, so from the corner to this road is about 5 millimeters. And then up this road is to Fresh Market Foods, which is kind of like here. Looks like it's about, let's say 13 millimeters. Okay, so sorry, using multiple programs trying to get them all working in line. Okay, so now we're gonna add these up. So we're gonna have 15 plus 25 plus 28 plus 70 plus 50 plus 5 plus 100 or sorry 13. So that's 206 millimeters. So 206 millimeters is the total distance that we measured from Hostel 2 to Fresh Market Foods. So then in order to continue to figure this out, now we're going to cross multiply. So we're going to do 18 times X is equal to 200 times 206. Remember, this is why it was important about that. We're setting our millimeters are both on the top and our meters are both on the bottom. And this is going to figure out how many meters it is. So 18 times X is 18X. And then 200 meters times 206 is equal to 41,200. 41,200. So now we need to divide both sides by 18 for the divide part. So 41,200 divided by 18 is equal to 2,288.9. So let's say 2,289 meters. 2,289 meters is the estimate distance from Hostel 2 to Fresh Market Foods. And that's how we would do it if we were using a ruler on a map. Or you could also, if you had a string, if we were in a classroom, we'd have a string, we would use a string and we could go on those curves and then measure the full distance. But this is the best way we can do it that I can show you online. Okay, I'm just going to close this down. Okay. So for the sake of time, we're not going to do another one of these examples. But we could do it for a larger space too. We were going from Mishkikugoman all the way to Sioux Lookout. We could do it like that too, the same way, measuring using a ruler. So you can now do the support questions on page 18, questions 1 through 3. All right, so now we have estimating distance using technology, which is probably more realistic to what most of us are doing. Most of us aren't using paper maps and rulers these days. So it's on page 20 of your IEL booklet, and it shows you, walks you through. It's how to do it through Google Maps, because you can use the internet to find distances between locations. It will also give you estimated driving times and directions. One site is Google Maps, which is google.com/maps. And many, it is updated. It looks different now than it did in your IEL booklet. So how it works is if you are looking for directions, so say we wanted to go from Mishkikugoman. So it zooms in and tells us where it is roughly. For some reason, Mish doesn't actually come up as a community. I don't really understand. But if say we're going from the school, so we're looking for directions, then we click on directions, and then you can put your starting point in. So if I say Sioux Lookout is my starting point, and then it will show me how to get there, and it'll say, okay, here it says it's 234 kilometers and an estimate of 3 hours and 17 minutes is how long it'll take you. If you go this route, it'll be different. You can pick and choose. Generally, we pick the fastest, the shortest in kilometers, and the shortest in time. So it tells you that here. It also tells you that here, over here, where you can then break it up and you can get the actual directions to go from Sioux Lookout to Mississippi School in Mishkikugoman. So it's fairly straightforward, is that you just have to type in, you're looking for this. Key is the directions button, and you can put it in where you're starting and where you're going to. So let's do an example. So using technology, find the distance from Red Lake to Ignace. So going back to our maps. So how we would do that from, if we just start right from Google Maps, you just type in Google Maps and click on it, or you can type in the URL. And then you'll get something like this, shows you the map of the world or the map of Canada maybe. And we want to start in Red Lake. So you can type in Red Lake. You want to make sure that it's Red Lake, Ontario, opposed to Red Lake, Minnesota. So Red Lake, Ontario. And then it's going to zoom us into where Red Lake is. And then we look for directions. So when you press Red Lake, and then you press the directions button, that little button, it's going to tell you how to get directions to Red Lake. So the second place is where you're going to. So you're going to type in your starting point. But we wanted directions from Red Lake to Ignace. So if I go over here, I can click on this reverse button and it switches it. It says that I'm going from Red Lake and then I want to go to Ignace. So again, Ignace, I can type it in and then select Ignace, Ontario. And then it shows me how to get there. And it gives me that it's 321 kilometers, which is approximately 3 hours and 40 minutes. So that is how you do that, is that it was 321 kilometers. That's all you do. So if we want to do the same thing to go from the distance from Dryden to Sault Ste. Marie, if I'm in here already, I can just change these and I can say, okay, Dryden to Sault Ste. Marie, start typing in and then choose it, click it, and then it shows me. Okay, so it shows me lots of options this time. So it shows me that I could fly from Sioux Lookout to Sault Ste. Marie, and that would take me 2 hours and 20 minutes, this straight line, right? Because driving isn't straight over water, but that's flying. Or driving. Oh, yeah. I think it says here, it might even tell me that I'm walking. I don't know what it's telling me. You're going from Dryden to Sioux Lookout. So that's not what we want. We want to drive the whole way. This way is telling me if I'm using public transportation, which I don't even know what that is because there's no Greyhound bus anymore. So you want the blue line that is this little car one. And so it says that it's 11 hours and 13 minutes and 1,032 kilometers. These numbers might be slightly different depending on when you're doing it, what time of day you're doing it, or what, but that's fine. If you're doing something and it gets something that's relatively reasonable, then I accept your answer. So it doesn't have to be exactly the same as, depending on the day, it switches. So that's how you use technology to find distances. And that's on page 22, your support questions, question number 4. So then I just wanted to, we have a few minutes to just look at the parts of paper maps, as I don't think this is too common. I was a geek kid who loved paper maps. So I spent a lot of time looking at them. I don't know if everybody else is, but again, this is what a paper map looks like on one side. And then on the other side is Southern Ontario, which has a gazillion little red roads. So you can see the difference between Northern Ontario. These red lines are roads, and Southern Ontario, where there's a gazillion roads. And this doesn't even show all the roads, it shows the main roads. Okay, so on a map, there's always a legend that tells you it breaks it down, this one does. So it's road classification, so it tells you the kinds of roads, if it's a freeway, if it's under construction, which if they're building it at the time of the map printing, highway, major road, minor road, and even smaller minor roads, and then other types of the numbers, the road names. Then it also tells you the size of places, the population, roughly depending on the dot. Look, Red Lake is under 10,000 people is the example, and Perkanchicum shows the First Nation community, shows you this icon. Then it shows you national parks and provincial parks, and then boundaries, and then other airports, your kilometer distance, which we're going to talk a little bit about, and other tourist attraction things. So there's lots of information in your legend, which is good to look at. This is also a paper map, has this distance chart. So how it works is if we look and it says, let's see, so here, Sioux Lookout is on it. So here, Sioux Lookout shows you all the distances to other places. So if we want to go from Sioux Lookout to St. Nipigon, then we go up Sioux Lookout until we reach the row that says Nipigon. I totally was just going to point to that with my finger, which would not be very helpful for you. So that tells us that it's 480 kilometers from Sioux Lookout to Nipigon. So this can be a useful way of just getting sort of an approximate rounded to the nearest 5 kilometers sort of idea of distances from some larger or significant places in Ontario. And then there's also these little paper map inserts, which show you smaller areas in a little bit more detail, zoomed in as much as they can, including this tells you like your time zone. There's a time zone line, and there's just different information. Again, I'm a geek and I think that these are super cool. One other way that you can measure distance on these maps is that they show you on paper maps, they tell you the kilometers. So if we want to go from Sioux Lookout to Mishkikogoman, from the star to the next star, this red line, this red number tells us how far that is. So from this red star to this red star, it's 104 kilometers. And then from this red star to Pickle Lake is 156 kilometers. So we can add those together and we know that it's about 260 kilometers from Sioux Lookout to Pickle Lake. So it's going to be a little bit less to go to Mishkikogoman, and you could use your scale on your map to figure that out. That's just another tool that is really useful. And you don't have to use a ruler to measure. So the last thing that we just want to talk about before we are out of time today is that when travel time changes depending on the weather. So when you are driving at night, your low beams, depending on how far you go, or sorry, how fast you're going, you might not be able to stop within the distance that your low beams or your high beams are showing. So for this example, we have a car going at 70 kilometers an hour with their low beams on, which have a range of 45 meters. So we see a person who's just outside at the end of that 45 meters. And because we're going 70 kilometers an hour, we can stop within 40 meters and we don't hit this person. However, if we are driving 80 kilometers an hour, it takes us 60 meters to stop. So now this person in this picture, if they were in the dark here where we couldn't see them, it takes us 60 meters all the way over to here to stop. So we are going so fast, there's no chance that we will be able to stop in time. So don't drive faster than your lights can show you. So basically, when you're driving at night, slow down. Basically, I don't expect you to know these distances. I don't know these distances. It's not something that I measure when I'm driving, but basically at night, you need to slow down so that you can stop where you can see, opposed to stopping where you can't see and hitting something because you don't know that it's there. It's too late. If you're driving on wet roads, again, it takes you longer to stop on wet roads than it is to drive on dry roads. So first, it always takes a little bit of time to react. So you're always going to, no matter what, even if you're driving 40 kilometers an hour, it takes a moment for your brain to react. And so your car is going to continue to move forward while you react. And then you're going to stop. On a wet road, it takes, if you're driving 40 kilometers an hour, it takes 4 meters longer to stop than on a dry road. So if the road's wet, it's going to take you longer to stop. If you are going 100 kilometers an hour, it takes you significantly longer you're going to stop to react. That react time might still be the same, but you're going to travel farther because you're going faster. And it takes 24 meters more to stop if it's on a wet road. So again, if your road is wet, slow down because it's going to take you longer to stop at higher speeds. The same idea is that if you're driving on packed snow, it's going to take you longer to stop. And if you're driving on icy roads, it's going to take even longer to stop. So again, you need to slow down. Basically, when in doubt, slow down. Also, your tires makes a difference. So winter tires on winter road makes you stop faster. All season tires make you take a little bit longer to stop, and summer tires take a really long time to stop. So really driving on snow-covered road, you should have winter tires on to really stop and have control of your vehicle. And then this is just one image to show that how far you can see depending on the weather conditions and how, again, you should slow down because it's the same picture, but you really can't see very well depending on if it's dense fog, heavy dense fog. Rain, you can see pretty good compared to heavy rain, you can see even less. Snow and extremely heavy snow, you can hardly see anything at all. So again, you can't see, don't drive very fast. Overall, the rule is if you can't see very well, if the road is not in perfect condition, slow down, slow down, slow down, slow down. Otherwise, it's going to take you too long to stop and you're going to get potentially hit someone or get into an accident yourself. All right, so just to wrap up as we come to a close for our time. So lesson 17, talking about traveling distances. So you can use on a paper map, you can use the scale or the given distances to estimate your distances on a paper map. Using tech, using Google Maps, there's that directions feature, which makes it really straightforward to get an approximation of how far and how long it is to get from one place to another place. And overall travel time in bad weather, slow down. It's going to take you longer. It's going to take you longer to travel the same distance if the weather is bad, because you need to slow down in order to arrive safely. It is better to arrive safely than to not arrive at all, even if it takes you longer to get there safely. So pretty much in any kind of bad weather, slow down. All right, so our success criteria that you can use the given scale and the measurements to find the distance between two places. You can use Google Maps to find distances and estimates of travel times, and you know that why it does make sense to slow down in bad weather and therefore having a longer travel time. As always, please reach out to me if you need support, if you need help with anything. My number is 807-737-1488, extension 2209. My email address is bronwyn.slate@nnec.on.ca. Connect with me through Facebook at bslate Wahsa and find the replay of all of our lessons on YouTube at bslate Wahsa. Thank you so much for joining me today. I hope you have a lovely day. Witch.